All right, welcome everyone. Thank you so much for joining us on this Friday afternoon to talk about what is one of at least our favorite topics, which is heat pump water heater installations. We have Nick Brown from the Build Smart Group and Gary Klein from Gary Klein and Associates, who are our experts today. And I just want to, before I get started, I just want to preface that this is meant to be kind of more of an interactive session than maybe some of our other webinars. So we really encourage participation. Feel free to jump in, to go off mute, ask questions, or type them in the chat. We really want to encourage this interactive experience, and you all have the experts in the field for the duration of the session. So I encourage everyone to participate. I think we're all pretty familiar with Zoom at this point, so we'll just keep going. And I'm sure most folks know what the Tri-County Regional Energy Network, or 3C-REN, is, but just as a reminder, it's a collaboration between our three counties, San Luis Obispo, Santa Barbara, and Ventura. And in short, our programs are meant to reduce energy use to ensure a more sustainable, equitable, and economically vibrant Central Coast. And the way I like to frame it to folks is that these programs exist because of all of us in the Tri-County region. Every time that you pay your utility bill, there's a small public goods surcharge that goes to us at 3C-REN, and we're able to reinvest that back into our community to bring those dollars to you all. That's what allows us to bring quality trainings and sessions like this completely free. Next slide, please. And some of those other programs we have, obviously today, we're in the middle pillar, our building performance training and Energy Code Connect, geared towards building professionals, architects, trades folks about energy efficiency and building performance. But we also offer incentives, and this is when we are giving dollars to ensure discounted upgrades for homes, single family and multifamily, as well as a fairly new commercial program for small to medium businesses, nonprofits, and public agencies. And then we also have other robust technical assistance offerings for farmers through our agricultural program and energy assurance services, which focuses on critical community facilities. Next slide. And with that, I will hand it over to our experts, Nick Brown and Gary Klein.
Thanks, Juliana. Hi, Gary.
Hi, Nick. How are you?
Doing great. I want to thank 3C-REN for sponsoring this. They do a great job with understanding their community and the needs of all the people in it for training like this. So kudos. We love partnering with you on classes like this because you get people to show up and be engaged. And on that note, this class really was intended to be a follow-up to some of the in-person trainings we've done up in the 3C-REN territory from San Luis Obispo down into Ventura and Newbury Park on installation of heat pump water heaters, focusing on the plumbing industry as a target audience. But I'm sure there's a diverse group here today. So to reiterate Gary's comment in the chat, we really want to hear from you on what your reason for being here today is. Perhaps challenges with understanding heat pump water heaters and how they work, or how to get them designed into your projects, or how to install them. And then we'll do our best to incorporate that as we go.
So
Gary, anything to add?
Yeah, a couple things. So while you all are thinking about why you haven't raised your hands yet or put something in the chat, please tell us why you're here. It really does help us make sure we're covering what you need. Nick, one of the questions we discussed earlier, people can just show a raising of hands electronically. Have any of you taken our seminars before on heat pump water heater installations? If you have, raise your electronic hands, if you can figure out where they are.
And don't sit on those electronic hands.
I see one. I see Finley. Cool. All right.
I know Vernon has come to trainings before. I know Cassandra has. I'm just going to start calling people out. Sarah has.
Right. I'm thinking specifically about the heat pump water heaters so we know what to cover. So we have most of you today have not listened to us before, so we'll take that into account. The other thing is that there are really two kinds of questions as we go through the slides. One, I don't understand something directly here on slide 4 or 6 or whatever it might be. Raise your hand then and we'll watch for them. And we'll try and take those questions as they come. If you want to figure out why the sky is blue, we'll discuss that at the end if we have time. Okay, let's get started, Nick.
Okay. And let's start with this thought-provoking starter, which is we probably all grew up in homes with tank-based water heaters. Many of us got used to designing homes and maybe living in homes with tankless water heaters, typically gas. And now with California's focus on heat pump water heater adoption, we're being asked to go back to the tank model. And I've found, Gary, in my practice, I'm an energy consultant, so I'm working with architects and builders and homeowners each day to design their project for energy code compliance with Title 24. But also, we work in a lot of conversation about the best systems and best technologies for a given client. And it quite often these days is a heat pump water heater that makes energy code compliance easier, that has the promise of lower utility bills, emission-free water heating, et cetera. And so some of the resistance I get on the other line is finding a room for that tank. I don't know about your experience, Gary.
Yeah, in new construction, we've been focused on gas tankless for what, a decade-ish, roughly. And so the last 500,000, quarter million, more homes have had that number in them, and it's a tankless, and we got rid of the space. I'm not sure what we're going to do in retrofit. And so
Yeah.
it promises to be challenging. The other thing about space is that manufacturers are currently tell us that you have to put the water heaters in a certain minimum volume, and water heaters go wherever water heaters go. Typically the smallest possible space you can put them in because you want the space for something else.
Yeah.
And I think that challenge is going to get harder as we move forward, as we go to more and more new occupancies. So
Yeah. And we found this training really wakes some people up to the subtle yet significant differences with these type water heaters on where to install them and how to install them. And you'll come away with a good understanding of that today.
So I have another question for our folks here today. How many of you have actually installed a heat pump water heater or been on a project where they were installed? Raise hands. That will help. And I see Finley's note. We'll take that into account.
Okay.
The answer is yes, Finley. We're going to cover that in some depth today.
Yeah. In fact, we weren't planning on covering it in much depth, but now we will.
Yeah.
Okay.
Cool.
All right. Well, we've got
Okay.
this organized today, hopefully with a lot of room for interaction, but why we need heat pump water heaters, how they're subtly different, those key installation things to get right, and a focus especially on airflow. And Gary and I are making use of an install project throughout the Central Valley where hundreds of these were installed and monitored for a period of several years. And so we've got a ton of install pictures, which are fun to put up there to show you the various different places they're operating in and the good, the bad, and the ugly. So let me kick this off by saying heat pump water heaters are an enabling technology of all electric buildings and all electric homes. Without them, we're using electric resistance technology, and it's vastly more utility expense. So the reason I'm starting today with a slide on electrification is because that's the reason heat pump water heaters have such an important role to play in California. Without them, we wouldn't be cost effectively electrifying buildings. And the reasons that all electric homes make sense to a big tent of people, a wide variety of people, is that it allows for one fewer utility when you're starting a construction project, which just makes everything easier, smoother, and less expensive. The state and to a lesser extent, the federal government have devoted billions of dollars in incentives for electrification of buildings. I like to say they're the low-hanging fruit when it comes to decarbonizing our economy along with electric vehicles. We find in California easier energy code compliance. To Cassandra's question earlier, their heat pump water heaters are a great enabler and smoother of energy code compliance. Maybe the biggest reason many of you are here is you've read about the hazards of gas combustion in homes and buildings, especially in cooking, because those cooking combustion devices are in our conditioned space, right? Emitting additional pollutants that electric and induction cooktops do not. And so the health reasons for electrification are significant. We've also got potential utility cost savings and lower greenhouse gas emissions in all electric homes compared to mixed fuel. Gary, I just ran the comparison in the new 2025 energy modeling software of a mixed fuel house and an all electric house. 70% lower greenhouse gas emissions once you take into account that grid of 2045 that
Sure.
Senate Bill 100 commits us to. So big difference. All right, let's start with why we need them. First, what's in it for you? There's large rebate money available right now, even though I would argue heat pump water heaters are a proven technology that don't need a whole lot of support with incentives. Those incentives are out there right now because California really wants to get this technology over the hump. And until recently, the tech program had rebates of $3,500 to the contractor. We've given you links to those program websites so you can check them out for yourself. But unfortunately, it ran out of money. That appears to be temporary. So watch that space. And when those rebates come back, will be your time to jump on your heat pump water heater retrofit project. And for those of you who are architects, plumbers, builders, general contractors, this is your chance to get comfortable with this new style water heater so your business can compete effectively against your competitors who are not as comfortable with it. We've also seen signs that California regulators are likely to require all water heaters sold in California to be heat pump water heaters relatively soon. Bay Area's Air Quality Management District has already passed a rule doing that by 2027. The effort in South Coast AQMD just fell short one vote recently, but it's likely to come back soon as well. So the writing's on the wall. So Title 24, our energy code, gives us a strong nudge towards heat pump water heaters. It makes them prescriptive standard in most of 3C REN territory for new construction. And I took a snippet of the climate zone map and put it on the screen here to show you all these gold regions, you're going to have a heat pump water heater prescriptive standard. And even in the gray regions, if you're in Paso Robles or somewhere like that, you're going to find an easier path to energy code compliance with a heat pump water heater there as well. And if you do put in a gas system for water heating or cooking, clothes drying, furnace, you're going to be required to install a dedicated electric circuit for the future electric version of that gas appliance to make it electric retrofittable. The 2025 Energy Code, which has already been approved by the California Energy Commission, will make heat pump water heaters prescriptive standards statewide. So all that is wind in the sails of heat pump water heaters. Now, incentives this time around are a little different than 10 years ago in that you can stack them. There's no incentive police who are telling you, well, if you took that incentive, you can't take this other incentive. So for instance, if you did a heat pump water heater project and qualified for that tech program rebate of $3,500, you could still also take up to a $2,000 tax credit write-off on your federal taxes and a little more for the electrical panel. So all told, that can be a $6,000 incentive to do a job that probably costs about that in most cases. And electrifying your whole house can add up to much bigger incentives. So because of the uncertainty in the incentive space right now, we're unable to give you, this is exactly what you're going to get if you do this heat pump water heater project. Instead, unfortunately, we've just got to tell you what those programs are and leave it to you to go research them when they become available, what they're worth, and we've given you links to do that. But I want to share this example from my practice. Steve Kramer is a developer in LA, and he built this. This is a rendering before they built it of a 4-story multifamily building on what was a single family lot. And he said, Nick, I'm no tree hugger, but it makes no sense to me to run gas throughout this building if I can do the job with electricity. And I was telling him he could, both from energy code compliance and a practical function standpoint. And so he trusted me, and that's how we built it. All electric, a heat pump water heater, either in each unit, or as I think it was Vernon who said, out in closets facing the hallways with louvered doors, ductless mini split heat pumps in each unit. And they had to upgrade the electrical service through the local utility, show that they met the energy code, and that worked well for him. And he was coming at it from a practical standpoint, not a greenhouse gas emission standpoint. See what I mean by a broad tent of people who can rally around electrification and heat pump water heaters. Gary, anything we need to tend to in the chat?
No, we're good.
Okay. Let me share with you this modeling results. It's what I do for a living, modeling for energy code compliance, but also modeling for optimizing sets of features in building projects. So if I model a new house that's shown on the left and I calculate the utility costs, I've got a very detailed spreadsheet for PG&E and SCE territory to calculate their utility bills. You can see the total annual utility bills in this house with a gas tankless water heater are about the same as with a heat pump water heater. Little bit of savings there. And if you were to program that heat pump water heater to run in heat pump only mode, to not run between 4 and 9 p.m., now you're going to open up a little bit more savings, perhaps $100 a year. But the myths that gas is always a cheaper way to run a house than electric heat pump technologies just aren't true, according to my calculations. Even retrofitting an existing home, so now we've got no solar panels on it on the home, about a push in terms of utility costs to go from that gas tankless to a heat pump water heater. So I want to be honest, I don't think you're likely to open up a huge multi-$100 savings with this technology. That is, unless you're currently using an electric tank water heater or an electric tankless, because these are going to cut your usage by 2/3.
Cool. Thanks for the
Julie,
picture in the chat. We'll look at it later. We'll bring that
yeah.
back.
And then another myth I wanted to address right out front is that of noise. So listen here, this was my old gas tankless water heater that was installed on the exterior wall of my house in Long Beach. And then you'll see the noise from the heat pump water heater that replaced it. See what you think in terms of the comparison. What do you guys think? Sarah says barely a difference. Yeah. Yeah, Danny, good point. And welcome, Danny, to the presentation. If that existing water heater is gas storage, it's going to have an efficiency of 56, 60%, and the heat pump water heater is going to compare really favorably to that. But I agree. I think people understate the noise of a gas tankless water heater and overstate the noise of the heat pump water heater. So I thought I'd show that to you. I've got two of these installed at my house, so it's a living lab. I collect their usage data on a continuous basis. So, and they've been working great for me. The one on the left is a 240 volt, 50 gallon, 30 amp model. That's the predominant configuration in the market today. And I installed it in the garage. Above this garage is an ADU, a one-bedroom ADU with two residents. They don't know they have a heat pump water heater. They just know they have reliable hot water. Been working well. The one in the middle is a 120 volt heat pump water heater that I installed to retrofit that gas tankless I just showed you the recording of. So that's where the old one was located. It already had a 120 volt circuit and outlet there. And so 120 volt heat pump water heaters are ideal for this type of situation where you already have that 120 volt power available, and all you have to do is reconnect all the plumbing in that location. And you can see on the far right, the enclosure I built around it once it was installed. Notice it's got a ton of louvered panels on both sides. That's to ensure adequate airflow in and out of that closet, which we'll talk a lot about today. I wanted to show you their usage. This is from my energy monitoring software, and it's about a 1 week period. Okay, the bottom chart shows the heat pump water heater for the ADU turning on, and each green bar is an on-off cycle. So I think immediately you notice it's not running a lot of the time. Even though heat pump water heaters are seen as having lower heat rates, which we'll talk more about, this thing has a ton of excess capacity for the ADU. It's barely running, and when it is, it's running for half an hour, maybe an hour. And it's using 400 watts. You notice on the y-axis 0.4 kilowatt hours. So it's super, like energy sipper is the term I use for it. The top chart is the main house heat pump water heater. That's the 120 volt model. And it's got a bigger heat pump on it, 12,000 BTUs per hour compared to the ADU one, which is only 4,000. And it's also got some other loads on this circuit. That's what you see at the bottom of the chart there. So if you can just avert your eyes on all that kind of background noise at the bottom of the chart and focus on the spikes, you see it looks like a very similar pattern to the bottom one, except it's using, you know, a little over 1,000 watts, maybe 1,200, 1,400 watts because of that bigger compressor. It too has a ton of excess capacity, even during this period where, you know, 3 or 4 people were in my house at that period using a fair amount of hot water. Sarah, I use a program called Site Sage. It's made by PowerWise. It's got a current transducer clamp that goes around every circuit, and then it uploads the usage to the cloud and tracks it. Unfortunately, they're not selling it for residential anymore, but you'll find other similar projects on the market. So all told, my 2 units are using about 50 kilowatt hours a month, or about $18, a very affordable way to make your water, hot water. They're both programmed to not run in electric resistance mode, but that electric resistance backup is very useful if you're putting this in a place that's likely to fall a little bit colder than 40 degrees, and you need that source of heat during those really cold days, or where you're going to have spikes in usage and you need that electric resistance circuit to take care of those spikes. But in our case, we haven't needed that electric resistance backup whatsoever. Anything else to cover, Gary, before we launch into what makes these different?
I think we should just keep moving.
All right.
So next slide. What's different? They use air as the source of the energy, not gas, not electricity, not purple cows. They use air, not the ground. These are air source heat pump water heaters. We need to pay a lot of attention to air going through the heat pump's compressor, otherwise, and getting out of the place it's located. Otherwise, they don't work as intended. And resistance, if they've got backup, takes over. Next slide. This is showing you the different configurations for most of the products on the market today in the United States. I want you to look at a couple of things. We're going to come back to airflow a little bit later, but start thinking about that now. There's top intakes and side exhaust, top intakes and a different side exhaust, top intakes and rear exhaust, top intake and top exhaust, side intakes and top exhaust. Nick has two of these at his house, the one on the left and the one on the right. Okay. In the chat, someone was talking about rear exhaust blowing air at the back wall. I'm pretty sure it's the one in the middle. And I want you to also look at all of the locations of the pipes that are attached to the water heaters. Nick, I think in the next slide deck, we should show an example of a gas and electric water heater to show how common they are on those and how different they are here. We're not used to it. And if you're doing retrofit or you're setting up new construction, everyone's setting up new construction for the gas or electric water heater storage or tankless that they did last time or for the last decade. These are different. It hasn't stabilized yet. Next slide. These are big ones. We can do central multifamily. We can do using outdoor air. These are CO2-based heat pumps, gang together or separate, big or small, doesn't matter, but we can do any size building if we design it right. Next. Looking inside a water heater. Cold water comes in typically through a dip tube. That's the blue thing there. Hot water usually leaves it on the other side coming out at the top. That's the old style stuff. The heat pump water heaters haven't stabilized for this yet. There's burners at the bottom, flues up the middle. There's an anode rod to protect the steel tank. If you don't have burners in your electric, there's resistance. Next. With what we're doing now, heat pumps are either small compressors or big compressors, and most of the unitary product, well, all the unitary products have a heat pump at the top of the tank, sitting on top, and that's what the air has to get in and out of. There's some way to connect the heat pump's compressor to the energy needed in the tank, typically with coils wrapped around the outside of the tank, and that's how they work. The time it takes to reheat the water that you use in a day is dependent upon the size of the compressor. If you have a small compressor like the one in Nick's garage, it takes a little longer than the one with the bigger compressor that's outside the house. Next. This is showing you unitaries versus split systems. Next. All right. Nick and I, you can choose, if you have the available product, between small compressors and big compressors and small tanks and big tanks to better match loads. And the idea is that it's a continuum with each manufacturer picking products in the middle of it somewhere. The first batch of heat pump water heaters were the ones on the far left. The one that Nick's has is the one on the far right. And you've got lots of choices in the middle, or we will in someday in the not too distant future. Next.
Right, and a gas tankless is a great example of that big element, big burner, small tank.
Right. They actually have a tank, right? Even if they don't, the volume of water in the heat exchanger, that's a small number above zero. But if you don't have a stored water somewhere, you can't actually heat it the way we do it today. So this is to follow Nick's earlier observation that heat pump water heaters are energy sippers. The gas storage water heaters are in blue, the heat pumps are in orange. And there's two things we pay attention to is first hour rating, how many gallons per hour you can make. And then there's a separate thing for the first hour. And then the recovery rate is what the thing will do, not including the volume that was already in the tank. And the key here is at the bottom for the energy, so the plumbing code in California for single family detached or apartments that have their own water heaters, the code says you have to meet these first hour ratings, which based on the occupancy you have in the apartment or house. And it looks to us that you can always pick a heat pump water heater that will match a case in this table.
Yeah.
Next. Nick and I have been working with a colleague of ours on a project in the Central Valley for some time now and monitored a lot of these 11 homes in the study at the moment, representative of over 100 installations. We're going to show more pictures of those today, the good, the bad, and mostly the ugly, I'm afraid, about the installs. And the hot water use varies dramatically. By the way, the method of test for determining the efficiency of the heat pump water heater is based on about a 55 gallon per day hot water use, which I would say is sort of at the low end of the occupants that we're measuring here. Things work and the efficiency is pretty high. Next. We wanted to show in comparison to natural gas water heaters or electric resistance water heaters, heat pumps extract energy from the air and they add it to the electricity they use in the compressor, and that's why they get a coefficient of performance above 1. So you get efficiencies that seem a little weird, but it's all based on stealing energy from someplace else that's not normally counted, and you get to use it. As long as that resource stays infinite, if you will, we can keep doing it. Next. Has anybody ever run out of hot water while they're in the middle of their shower? Know somebody who has. Used to happen to me on Thursday mornings. On Thursday mornings, the school district told our kids to get to school an hour later. I got smart kids. They got up an hour later. That put them in my shower window. Have you ever had a useless conversation with a teenager or been on the receiving end of one? Me too. I decided not to have the conversation with my son. I would just get up at my normal time and shower before my wife, and my wife would shower when she showered, and our son would shower when he showered, and no complaints, ever. I'm surprised. He's a teenager. It's their job to complain. He came home from college a few years later, and I asked him, how did you know it was time to get out of the shower? And he said, I ran out of hot water. It's the third shower, it turns out, in most households with water heaters of the type we have. We had a gas storage water heater. That's why people were so enamored of tankless gas water heaters. Technically, you couldn't run out. You run into different issues, but you shouldn't run out in a given shower running at one time because it'll go on forever. And I figured if we gave our teenager a gas tankless water heater, he'd still be in the shower and in 8th grade because he never would have gotten the signal to get out. The key here for this slide is that under a 50-gallon tank, you can't get 50 gallons out. You only get 35 in hot water in one go. You have to spend energy to reheat the tank again in order to get more hot water. It limits the length of time you can actually take a shower. The faster you move the water or the more showers at the same time, the less time you have for that exercise. Next. One of the questions in the chat was how fast can these things heat water? And Nick mentioned it as well. Most of the units on the market today are in the first row, the 240 volt category, with heat pumps that are small and resistors that are typical at about 15,000 BTUs per hour. What it means is it takes longer to reheat the tank because the job of the heat pump or the element is to reheat the tank, not keep up with flow. LG has an interesting one that's new on the market. It looks like it might be as much as 10,000 BTUs per hour. And the resistance element, I think they put in is a little bit bigger. Instead of 4,500, it's a 5,000 watt element. So you get a more capacity on that. A.O. Smith's 120 has some backup in it. And Rheem has a dedicated circuit like Nick has with no backup in it and a bigger compressor. The key is the size of the heat rate into the water. That's what matters. Okay, next slide. Keep going. Tankless water heaters don't have standby losses. They don't take up floor space. They're inexpensive compared to other things. And Title 24 allows them Oh, it should say electric tankless water heaters only in new small homes, right? We're talking about switching to electricity a lot. Electric resistance water heaters are challenging. Tankless are great. They turn on when you need them, turn off when you don't. The way the energy modeling works is it assumes a certain amount of use during the peak periods in the electric grid. And if the tankless water heater comes on during that period, it gets penalized because it's creating stress on the grid. There takes a fair amount of energy to heat water electrically. It takes approximately 10 kW to heat 1 gallon of water per minute with a 70-degree temperature rise. That's a pretty typical set of numbers for water heating. If you need 2 gallons a minute, you need 20 kW. It takes capacity. If you want to use electricity to heat water and you want to take advantage of efficiencies that are available, heat pump water heaters are a much better choice. Next.
Yeah, I say the only thing you should be doing with electric resistance is making toast.
Fair enough. All right, let's look at some pictures now. We'll get there. Heat pump water heaters need electricity. Keep going. There needs to be an adequate supply of warm air. We're going to come back to that, so let's keep going. If you need warm air to come in, you must also get rid of the cold air somewhere else that doesn't stay in the same place. Heat pump water heaters have filters. Most people don't like to change filters. We have to pay attention to this. They have condensate that's safe. Condensate is it's just water, but you have to dispose of it. Noise we've already discussed. It may or may not be an issue. If you're going to use the water heater as a storage mechanism, and you want to do that, you're going to raise the temperature of the water heater. You need to put in a master mixing valve. Some units come with them built in. I'm leery of that, but you have to make sure it's an ASSE 1017 only. That standard allows for mixing, not fundamentally a limitation on output temperature. They don't like warm, cold water. Next. And so if you go into a building that has a recirculation loop or a solar thermal system or other source of warm, cold water, you have to think about it carefully. Water heaters go where water heaters came out of, and the building is telling us that it might need recirculation because it's a big building and it's all stretched out, and you don't want to wait 6 hours to get hot water in any given apartment. You have to pay attention. Next. I was exaggerating, everybody. What does the code say about installing in garages? Because garages are a pretty typical place for water heaters in California, right? Whether they're tank or tankless. And the code is very clear. But it's new in the California plumbing code. That section that says, shall be installed all heating elements, switches, burners, and ignition devices not less than 18 inches above the floor, with one exception, flammable vapor ignition resistant appliances. And water heaters, storage water heaters have been that way for a while now. Next. So we went back and looked at Nick's garage. Nick and I worked on that project together, and when we read the code then, we didn't need a platform. The height to the element is about 10 inches. You need an 8-inch platform. Next. The problem with an 8-inch platform is it's going to be really hard to access anything on the top of the water heater once you do that. And since this has a vertical filter, it will be almost impossible to take the filter out correct without bending it. So if we had to do that today, we'd have to move the heat pump toward the workbench by 2 feet so we could clear everything. Next. Nick, you get to do this one.
Yeah, this is a case study from my practice. This was a detached garage with the house behind our backs looking at this photo. And the client told me, yeah, we're going to go all electric. So design in that heat pump water heater. We're going to put it in the garage, they tell me. What they don't tell me is they're putting it in this exterior facing closet of the garage, not the garage. And so they complain to me. They're triathletes, by the way, so maybe they take longer showers than us mere mortals. But they complain to me that it runs out of hot water way too fast, and it must be the heat pump water heater. And they've read about it now online, and these really are bad devices, they say. So here's what I see when I go to look at the install. First, I find they're in this closet. with a tiny little grill for ventilation. That's supposed to allow the warm air in and the cold air out? I don't think so. And a recirc pump, which is shown there on the right side picture, programmed to turn on at 5 a.m. and send that hot water under the walkway, the concrete walkway, back to the house. So much of that usable, this is a 50-gallon, I think, much of this usable 35 gallons of hot water is going to warming up that slab and warming up the pipes, not being ready for their showers. So it was a perfect storm of bad situation, plus a 5 gallon a minute shower head in the shower. So once we corrected all these issues with fully louvered doors, a push button control scheme for the recirc pump, and code compliant shower head, they've been happy ever since.
Thank you. And Nick, if you remember to do the click second, then you'll get the arrows on these things.
Next time.
All right. So this is a closet. Unclick it. Go backwards so we can see it
Okay,
again.
I'm sorry, I gave the answer already.
No, that's okay. So what do you see here? That's the point of this exercise, right? Look at the size of the louver. Look at this, have to step over the pipe to get things connected, right? Go ahead, go the click. And look at the little gap under the door. Okay. The instructions from manufacturers say this is sort of okay. What you're not seeing here is that the closet is another foot and over a foot above the closet is to the ceiling. The best place for the louver is not in the door, it's in the wall above. Why? You want to create a circulation loop, thermosiphon loop. You need elevation to make it work right. So the louver should actually be at the bottom of the door, and there should be a separate one above if you wanted to make it work right. Next slide. This is in a garage near a door. That's a pretty typical situation. In California, we find places like that, and the door is exactly where it takes so you can walk past the water heater on your way out to the backyard. This is very typical. Oh yeah, pipe insulation. We'll give them credit. It might not be finished yet. Hint, hint. I would also observe that there's no easy way to install pipe insulation on the pipe that's next to the wall. You're supposed to insulate the first 6 feet or so, 8 feet of cold water pipe and hot water pipe. And I don't know how to do that without taking off the straps where it's so nicely tight to the wall. It's too tight to put insulation on. Not thought through in design and installation. Notice that the T&P valve is oddly not connected yet. I hope to God they're not finished yet. And the airflow is sort of, if you look at the water heater, it's the controls are at the diagonal, and that's to help make sure that the airflow is blowing not at the wall, but out sort of toward the doorway, more into the space of the garage. Some good things, some not such good things, but work to be done. Next slide. Oh, a nook. Great. Does this water heater belong in a nook? It's right. I mean, think about it. Where's the air got to blow? Toward the side. What's going to happen if you blow cold air at that wall for 8 hours a day? One of the questions in the chat, do you have to pay attention to condensation on the wall? The answer is absolutely.
Yeah.
Right. Will the temperature of the wall go below the dew point? Often. Yes. For many, many hours. Heat pumps are slow. Next, please. Just click it. There's also a circulating pump. It looks to me like it's one that actually has an on-demand control, but you need to verify that. On-demand controls work well with heat pump water heaters. Virtually all other control strategies do not. Ooh, this one's entertaining. This one has ducts. It has an intake duct and an exhaust duct. Which one's the intake duct? Anybody guess? It's the
No
one on the
guesses
top.
yet.
Yeah, it's the one on the top. Yeah, very
Dave got
good.
it. Sorry, got
Yeah,
it.
that's great. So hit the next slide. Just click it. We'll have the arrows. Small intake duct. Nice, reasonably well insulated exhaust duct with 2 different dimensions on it. That part's confusing to me, and none of them match the supply duct. Yeah, that might be a draft diverter. But it might not be. That might be the collar that attaches from the manufacturer to the oddly shaped intake. It is a half moon shaped intake and someone had to make a collar to do the attachment. But from this angle, boy, it looks like a draft hood, a draft collar, draft diverter. And Danny's note is correct. Non-demand recirc is technically not allowed, but an awful lot of circulators are there already, and a lot of people don't actually read the code. So it's an entertaining problem in the real world, Danny. All right, next. Ooh, another closet. Ooh, so exciting. And Juliana, you put some in the chat. If you could pull one of those ready to show, I think it'd be great. It's a similar problem to this closet. And so what's wrong? Tell me what you see here. What's good? Is there anything good? If you look to the right, I don't think I pointed this out. You see that, Nick, can you use your cursor on this or not?
On what?
On this slide. I want you to go down to the white thing right below where you are.
Mm-hmm.
That appears to be a connection to let things like condensate drain out. Look up above. You see the condensate drain going into it?
Mm-hmm.
Interesting. Fascinating. But I also think that the T and P might be connected there, and that's not actually legal. Anyway, always entertaining to see retrofits. It's fascinating. The louvers, by the way, are painted. I want to know how many times you get to paint it before the louvers are shut.
Mm-hmm.
I've seen them. This is at the front of a garage. This tells me that there's an extra 25 feet of pipe between the water heater and the house than would have been if the water heater had been at the other side of the garage door next to the wall of the house. Somebody made that decision a long time ago when they put in the gas lines for the original water heater that were here. I personally think that you need to get hot water sources closer to uses, and that's perhaps what I'm best known for in our industry. But this is a classic case of this is where the water heater came out. I'm putting another one back. Plumbing is the plumbing. Doesn't look too bad on the top. It's a little tight, but tell me where the exhaust air is blowing. It's blowing straight at the little wall between the garage and the corner of the garage door in the corner. It's like 4 inches away. It's going to get real
Mm-hmm.
cold. Is it going to do anything damage? I don't know. But it's not getting rid of the air properly. Next one. Ooh, nice, neat looking plumbing. What do you think, folks? Oh, sorry. My dog is having heartburn. Nick, why don't you cover these slides for a minute while I go back to the dog?
Okay. Yeah, they've done a nice job of rotating this unit so that the outlet, which is facing right at us, is not blowing on a wall. But look at the top of the unit. This is a top intake side exhaust, and that filter pulls straight up right there by the D34 notation on the conduit. There is no physical way that this homeowner can keep this unit operating because that filter is going to blank over. So this is an installer who does not understand the technology. And I'll further add, my sister had one installed in LA and the filter was completely left out of the unit. My brother-in-law had one installed in LA and the contractor never mentioned the filter. So I'm glad you all are here to make sure you understand this technology.
All right, keep going. Ooh, nice. What's going on here? Can anybody guess? The environment where the water heater is installed is very full of dust. It's pulling air. It's a fan. It's going to suck air in and blow air out. And you absolutely want the filter to protect the coil. Ooh, I like doing the knitting for the sweater. This is great. Next. Yeah. Sloppy plumbing, lots of dust. We need to think better about how to protect the coils.
And again, no way to maintain the filter.
Yeah. I pointed, you can see it here as well. You see the remainder of the B vent hole?
Mm-hmm.
It's fine. It's there. I hope it's rain tight at the top. because it's dropping right on top of an electrical device. That will be fun in a rainstorm. But hey, it's providing some fresh air, I guess. This one's good. Look at how the piping sticks down. Where does it stick down? Right over the filter. Next. You'll get them. And the arrow. There's no way.
Mm-mm.
So whoever's doing the install is not paying attention to the clearances that are needed for proper, operation and maintenance. We have to pay attention to them, and they're different. Oh, this is one of our favorites. Tell us
Yep.
what you see, folks. I see really nice exhaust duct, good diameter, nicely taped. I don't like tape perhaps, but hey, it's what we can use. It makes sense. It's good tape choice. Would you click, please? And again. And again. What's that thing on the upper left?
It actually is not Finley's gas as an intake air duct. What else could that be?
Look down to the left. What's that thing sitting in front? It's the dryer. Oops.
Yeah.
Somebody, hey, they listen to they listen to what we're talking about. These are supposed to have a source of warm, moist air. Oh, my dryer. It's a really good source of warm, moist air. So let's connect it so it can dump into it. By the way, that's an illegal installation of a dryer vent because there actually wasn't one in the space. They were just dumping into the space anyway. Next slide, please. And notice all the dust bunnies and the filter. This has been cleaned. It's terrible.
Yeah.
Whether
By
it's
all means, locate your heat pump water heater near a source of waste heat, but not this waste heat.
Yep. All right, next. This is a new installation in an ADU up near Sacramento. Keep going. Just keep clicking. Reasonably neat piping on the top. I could make suggestions. Notice that there's a standoff to the wall. Keep going. Notice the dimension of the standoff. Those look like 1x2s. And the arrows, please. And then this water heater, back up a second. This water heater by manufacturer's installation instructions says the distance between the vent on the rectangle on the left and the wall in that right-hand picture needs to be 7 inches. And I'm going to suggest that's not 7 inches. It's not even half of that. Okay. And so it works. It's working, right? But it's blowing cold air in the 50-degree range at that wall all the time. The louvers are big enough to accommodate the energy exchange. Not my ideal installation. Next, please.
I told my friend who was building an ADU recently, and this is a picture of it, call me before you do the water heater. And he didn't. And I went by to look at it. I looked at this closet and I thought, okay, they put it in a standard water heater enclosure. It doesn't have the airflow I would want for this thing to really work efficiently. And gosh, that really isn't that tall. I didn't think heat pump water heaters would fit in those. Took the door off, and it's an electric resistance storage water heater. And he thought he was getting a heat pump water heater installed, and they put it on a stand for no good reason. So just goes to show you that you all being at a class like this is extremely important, because we need to get these things right out of the gate. Our
And I'm pretty
industry is
sure
still adjusting.
I'm pretty sure the permit for the ADU assumed it was a heat pump water heater as
It
well.
absolutely did. Yeah.
Yeah. So at least a few things went wrong. Keep going. We're almost to the end. This I like a lot. Drain lines tend to get gunky because stuff grows in the pipe, right? Nothing flows very fast. And the idea is that once every so often you could add a little bit of bleach. The idea of this is he set up a stand to do this, so it's easy to make sure you do it. And he leaves the red thing there all the time, so you remind when you walk by, oh, it's time to put bleach in. The controls that are on the water heaters now generally allow for you to communicate with it. either during setup or later on. Next. Nick, I
Yeah,
think you need to take over a little bit. I got to clear my voice.
you got it. We covered these intake and exhaust locations. So just as you're installing yours and starting your projects, think about the right model for the situation you have. Because as we tell the plumbers, your favorite brand may not be optimal for a given install. Sometimes you're going to want that top in, top out situation. Sometimes you're not going to be able to tolerate that exhaust spitting out the back or the side. Um, so get familiar with the various models, very much still evolving this product line. So watch this space. Preview of the 2025 Title 24 code. For the first time, the energy code's focusing on ensuring that these systems have adequate source of warm air and an adequate place to put the cold air. And so it's saying, okay, if you're going to install this without ducts, it needs to be a big enough space, or it needs to be a space that vents to another space that now is a big enough space. And if so, the vents that connect the space it's in and the larger space need to be big enough to allow enough air interchange. And it's as a function of the heat pump compressor size. Notice that it's plus 25 square inches per kBTU per hour of compressor. And we often in our longer class cover a study called the Amazing Shrinking Room, which determined that the best way to connect these small spaces to the larger spaces is either a fully louvered door or a high and low opening if you're not ducting it. And if you are ducting it, there are requirements for that as well. Anything to add, Gary?
Yeah, do the click. Um, it turns out that space volume, since this was published and discussed by the Energy Commission, we have learned much more about the installations. And it turns out that space volume itself, a room of a certain size, isn't the issue. It's the energy that's needed by the heat pump. So if Nick and I were writing this today, we probably wouldn't want that provision there. And we're teaching you how to make sure you get enough air. Next slide. We've said this before, there needs to be that. I did a presentation earlier this year that's been recorded. The link is there. It's an open source link. It covers all these issues. Next slide. All right, so here's an example of a failure in a garage. Notice the missing ADU. The exhaust air from this heat pump was blowing straight at the metal cabinet of the ADU and the duct that
Not
goes up to the,
ADU, air handler
sorry,
unit. Yeah.
sorry, I'm tired. What are you gonna do? So the air handling unit is missing, so is the main supply duct into the manifold at the top. And it died. You need to not blow cold air at surfaces that could go below the dew point. This happens to be Virginia, high relative humidities, high dew points. It happens. This is showing you how to go back one if you could, please. This is showing a similar problem in a closet, also in Virginia. The exhaust for this unit blows straight at the back wall, per Finley's question earlier. It was not far enough away from the wall, but that's not the relevant piece. New warm air coming in through the louver is above the dew point. The cold air is below the dew point, and moisture is condensing visibly inside the closet, not just in the cavity between the walls and the closet and the outside walls. This is showing you a schematic we've got in that presentation. That shows you how you can think about the space requirements of the heat pumps. Next.
And Juliana, did you want to introduce this survey and then we'll finish up with our last few minutes?
Yes, yes. We're coming up on time, about a minute, but I did launch a poll. If you could please take those questions, short questions before you leave. And then I'll pass it back to you all and you'll wrap it up.
Thanks.
Yeah, we're not going to make it by 1 o'clock. We're going to be a little longer, and those who stay, great. And if not, it'll be recorded.
Exactly.
Yeah. We've given you a few pointers here on how to talk with clients and other stakeholders about these water heaters. Make sure they understand that they're not creating every single BTU. They're actually taking it from the surrounding air that the sun has already heated for us, right? They need airflow to get that heat from the air, and hence why you're hopefully working so hard to ensure they have it. Learn when to use the 240 volt, the 120 volt, the split system, the unitary products. Upsize the tank size is a really good rule of thumb because we showed you that recovery rate is lower than the gas tanks that we're used to. And use those venting options that work. Ducts, louvered doors, or adequately sized top and bottom grills. So we generally can sometimes get by with less than a 4-foot square footprint, but best case is to have that 4-foot square footprint, 8 feet tall to ensure enough room for changing filters and air to get in and out. Again, focus on airflow. Make sure you have capacity serves the loads of that client. If they have a 100-gallon soaker tub, that's going to impact what type of heat pump water heater you install, and if indeed a heat pump water heater is ideal for that client. You can get by with the 240 or the 120 volt electrical sources, but make sure you have a plan for getting that condensate either to a sewer or to landscape, as I did with that garage unit of mine. Think about noise, and maybe that split system would be better in some cases if you don't have an optimal location to use, and provide for maintenance.
Do not locate your water heater in a small closet. I think we've made that point clear.
Yeah.
And do give it enough access to new warm air and get rid of the old cold air. You've got to manage it.
So we hope we've convinced you, if you weren't already, to add heat pump water heaters more into your business, whether you're energy consultants like Sarah, or plumbers or builders or architects. Good incentives right now there to give you that little oomph you might need to get over the hump. They're clearly where the state's going. They work, they're affordable to run, and are zero emissions. And there are our contacts. We'd love to hear the challenges you're facing with getting this technology rolling, or help you through difficult technical challenges. So please do reach out.
Yeah, we'd rather help you get it right rather than have you call us when it didn't. We have one more question, two questions actually in the chat from Danny. Can you explain why one would want to increase the set point above 120, and what is a JA13?
Yeah, happy to. Danny's with the California Energy Commission. Thanks for being here today, Danny. Capacity, as we said, is a challenge with heat pump water heaters, especially compared to gas tankless water heaters, which effectively have no maximum capacity, or virtually none that you're going to exceed in a home. So by setting your temperature set point above 120, well, that proportionately increases the hot water capacity by that same increment above 120 that you set it. So we see them commonly set at 140. So that's the reason one would want to do that. In addition to that, there's a lot of excitement about the ability to shift load in and out of peak period using heat pump water heaters as the storage device. They can take excess solar power during the day when your house may have more than it can use, and then skate through peak period because they've got a 140-degree tank there that's barely losing any heat and perfectly adequate to get you through any evening showers without running the system. And so JA13 specifies how a heat pump water heater needs to be designed and installed to be able to serve that load shifting function. And Danny, if I left anything out, please jump in. You know it better than I do.
There's one more question in the chat about why we had so many of these 140-degree thermostatic mixing valves in there. And the reason was it was intended for a load shifting project that Edison was running at the time. And so they wanted to see what they could do by doing that. So there's things, if you have a water heater at a higher than you need set point for actual use set point, then you can use that extra heat as a thermal battery. And you can use that battery function as a way to use the grid more efficiently. But once you start going up above 140, you now have to pay a lot of attention to managing scald risk, and that's why the master mixing valves are there.
Just a quick click through to show you we've given you a link to these various tech sheets of the various manufacturers' products that might save you a little bit of time, and some additional resources that we knew we wouldn't have time to get to today. Juliana, you want to bring us home?
Yes, thank you so much for that. And just want to highlight some other resources available for free through 3C Run. So if you have any questions about Title 24, we have a free code coach service. You can submit your queries online or call during business hours. And our energy code coaches are local experts and can answer your specific Title 24 questions. I think there's another slide. Yes. Right. So we mentioned in the chat, slides and recording are coming to you soon. Here are some examples of some other upcoming water heating courses. I don't think it's on the slides, but I also just want to highlight that we are doing a free multi-day training for EMU Passive House certification. So I can maybe drop a link to that in the chat, but it's also available on our website. Would encourage everyone to take advantage of that. Please take the survey before you leave. And with that, thank you so much for coming to this webinar on Friday.
And if you loved Gary, August 20th, best practices for hot water distribution is going to be Gary.
Great. Thanks all.